Hi students, welcome you all to Civil Ed. I am Shiva Prasad from Civil Ed team. In our previous video, that is Friction Lecture 1, we had learned about the theory on friction from engineering mechanics point of view. In this video, we shall learn to solve problems related to friction. Accordingly, we have the following types of numerical problems in friction, namely blocks in impending motion, blocks on horizontal plane and blocks on inclined plane. Next, problems on rope friction, problems on ladder friction, and finally problems on wedge friction. So these are the usual types of problems to be studied by the undergraduate students belonging to any university. So now let's begin with a basic problem on friction. So problem 1, find the value of weight W so that 980 Newton block shown in figure should not start moving. Consider the coefficient of friction between the block and surface to be equal to 0.3 and the pulley may be assumed smooth. So this is the given problem, and we have a sketch being given for this problem. So there is a 980 Newton block resting on the horizontal rough surface. Because we are solving problems on friction, the surface is not smooth, it is rough, because the coefficient of friction between the block and surface equal to 0.3, it is given, it is a rough surface. And this block, 980 Newton block, is tied with a string which is suspended over a frictionless pulley by a weight W. So this is the weight whose value is required to be found so that the block should not start moving, that is the motion in impending motion situation. You need to find the value of W. So to begin to solve this problem, the first step would be to draw the free body diagram for the block. So I consider the horizontal x-axis and the true vertical as y-axis, and the block will be placed exactly at the center, and the first force in the free body diagram would be the weight of the block itself, that is 980 newtons. To counteract this, we have a normal reaction that comes into picture, represented by N, acting in the upward direction. Just because this block is tied with a string and it is suspended to a weight, this tension in the spring will act as an applied force acting towards the right, whose value will be equal to the weight of the weight suspended. So just because we considered the weight to be acting on the right side, that is, this applied force will try to pull the block, 980 Newton block, onto the right side. So the motion will be the motion of the 980 Newton block will be towards the right. So opposite to the direction of motion, we will consider the frictional force. We consider the frictional force in the direction opposite to impending motion, or opposite to the motion of the block. So it is left side force. So this completes the free body diagram, and using this free body diagram, let's solve the problem and find the weight W. So now, to begin with the solution, we need to check this statement carefully. So in the question they have mentioned the block shown will not start moving. That is, they have asked you to solve this problem for impending motion situation. So what is impending motion? The impending motion means the block, if it is in the verge of motion, the frictional force will be maximum. So that situation of the block is called the motion is impending. So to learn this in detail, please look into our previous video wherein we have discussed the friction theory in detail. So you'll get to know what exactly is impending motion, and in the phenomenon of friction, how exactly the static friction and dynamic friction comes into picture. So all those things you can just learn from our previous video. So therefore, just because the motion is impending, the frictional force will be limiting friction, that is the maximum frictional force. So we can use the relation F equal to mu times N. Mu is coefficient of friction given in the problem, and N is the normal reaction force. So F is equal to mu N equal to 0.3 times N. This value we can use in solving this problem. So applying the conditions of equilibrium. So the conditions of equilibrium will be sigma V equal to 0 and sigma H equal to 0. So let's apply the first condition of equilibrium, that is algebraic sum of all vertical forces equal to 0. For this, the sign conventions would be upward forces positive and downward forces negative. So resolving these forces along vertical, we have a downward force 980 Newton and an upward force N. So plus N minus 980 will be the equation for sigma V. Why minus? Because it is downward force. That is the sign convention we are following. Downward, negative. So solving this, we get the value of N, that is normal reaction force N equal to 980 Newton. I have written this units completely in words, that is Newton, because you should not confuse this normal reaction, the notation for normal reaction N, and with the unit Newton. So 980 Newton is the value of the normal reaction force. So moving on to the next, that is second condition of equilibrium, sigma H equal to 0. So we consider right side forces positive and left side forces negative, and which are all the forces along the horizontal. Right side force W and left side force F. So two forces only. So right side force W positive and left side force F negative. So minus 0.3 N. This is nothing but the value of F. So we have got from limiting friction formula 0.3 N equal to 0, or W will be equal to 0.3 Newton. Substituting the value of N equal to 980 Newton in this equation, we get the value of W to be equal to 294 Newton. So this is the simple most problem you can think of to understand the nature of friction force for the applied forces and nature of normal reaction force for the applied loads. So moving on to the next problem, problem number 2. Find the range of values the weight W should have so that 980 Newton block shown will neither start moving up the plane nor slip down the plane. Okay, two cases they are asking. Will neither start moving up the plane nor slip down the plane. So two cases they are asking. Consider the coefficient of friction between the block and surface to be equal to 0.3. Coefficient of friction mu is given, and a pulley may be assumed to be smooth. Okay, so for this the given sketch is like this. There is an inclined plane, inclined at 20 degrees to horizontal, and the block 980 Newton block is placed over this inclined plane, and further this block is attached with a string suspended to weight W. So the main difference we are able to see with the previous problem, that is problem number 1, and this problem is the block is placed on an inclined plane, wherein in the previous problem the block was placed on the horizontal plane. That's what are the type of problems we have listed in the beginning. So for this given sketch, let's draw the free body diagram. So free body diagram for upward motion or impending motion of the block. Upward impending motion, that first case we will consider. As I told you before, we have two cases, that is, will neither start moving up the plane is one case, nor slip down the plane is another case. So first case we will consider for upward impending motion of the block. So the free body diagram will be as such. So I am considering the inclined plane itself as the x-axis, and perpendicular to that I choose the y-axis. So what is the convenience in doing that? I'll tell you in a short while. So the block is placed exactly at the center on this inclined axis, that is x-axis, and the weight 980 Newton will be acting vertically downwards, because it is weight, it acts vertically downwards, and we have the normal reaction force, always it will be perpendicular to the inclined surface. Okay, so the normal reaction force will be acting perpendicular to the inclined plane in the upward direction, and we have this string tied up with the block. So that is the next force you can consider, that is the force which is applied force onto the right side direction. And just because this case is for impending motion of the block in upward direction, the motion is impending upward, so frictional force will be opposite to that direction, that is downward. So left side force we can mark the friction force. So this is the free body diagram for the case upward impending motion of the block, that is what will neither start moving up the plane. For that the friction force is in the opposite direction, that is left side. Now for let's look into the free body diagram for the next case, that is the plane it will slip down the plane, that is the second case. Look into the free body diagram for the second case. So free body diagram for downward impending motion of the block. Downward impending means sliding down, nor slip down the plane. For that case, this is the thing. For downward impending motion of the block, the free body diagram would be, again considering the x-axis on the inclined plane, and perpendicular to that I choose the vertical axis, and the block is placed at the center, 980 Newton, that is the weight of the block acting downward, and the inclination of this 980 Newton block with the horizontal is 20 degrees. Sorry, the inclination of the inclined plane is 20 degree, and so the inclination of the weight, that is 980 Newton force, would be 90 minus 20, which is equal to 70 degree. Next, the normal reaction force acting vertically upward perpendicular to the inclined plane, and the weight attached with through this string, that is acting in the right side direction. Now for downward impending motion of the block, that is if the block is in the verge of sliding down means the friction force should act to be in the opposite direction to the motion that happens. So if the block slides down, the friction will be in the opposite direction, that is the friction force is assumed in the right side direction. So this is what you need to understand. For upward impending motion, friction force is in the opposite side, that is downward, and for downward impending motion of the block, the friction is in the upward direction. So for these two cases, let's find the value of W. So considering the first case for upward impending motion of the block, so we have this friction force on the left side. So for this case, let's see let's apply the conditions of equilibrium. So one thing I'll tell you why we chose the inclined plane itself as x-axis, because if you see, all the forces are almost with respect to the inclined axis, and the normal is perpendicular to that. Only one force we will have for resolution. If you consider true horizontal, you can do that also. If you consider true horizontal, then you will have more forces for resolution. So for that convenience, I have chosen the inclined plane itself as x-axis. So applying conditions of equilibrium, that is sigma v equal to 0 and sigma h equal to 0. So for algebraic sum of all vertical forces equal to 0, for this condition my sign conventions would be upward forces positive and downward forces negative. So along the vertical, which are all the upward forces? Plus n, that is one force, and minus 980. See, 980 is not along the assumed vertical axis. 980 is not along the y-axis assumed, so you need to resolve that. So downward force negative minus 980 sine 70 degree is the resolved component of 980 Newton force along the vertical direction. Solving this, we get n equal to 921 newtons. So moving on to the second equilibrium condition, right side forces are assumed positive and left side forces are assumed negative. So right side force is W plus and left side force F minus. So W minus 0.3 times N. What is this? It is nothing but F. So from where we get this? F equal to mu times N, that is the formula. So mu is 0.3 given in the problem, and N is the normal reaction force, minus 980 cos 70 degree. This is the resolved component of 980 Newton force along the horizontal direction. So this force will be resolved on the negative x-axis. So minus 980 Newton, sorry, minus 980 cos 70 degree, that is equal to 0. So now we can substitute for n equal to 921 here and get the value of W. So W works out to be 612 Newton. So value of W for upward impending motion of the block is 612 Newton. So that is the maximum weight we can imagine of. If the weight of W reduces, then that might cause this block to slide down. So that is the second case. Let's see and solve the second case. So that is nor slip down the plane. For that case, case 2, for downward impending motion of the block. So applying the conditions of equilibrium, sigma v equal to 0 and sigma h equal to 0 for downward impending motion of the block. So we have considered for downward impending motion of the block, where the direction of friction force F will be in the opposite direction, that is towards the right. So sign conventions for sigma v equal to 0, upward positive, downward negative. So equation is plus n and minus 980. 980, of course, it has to be the resolved component has to be taken, minus 980 sine 70 degree equal to 0. For this, n is equal to 921 Newton, no change in the value of n. So further, second condition of equilibrium, left side forces negative, right side forces positive. So we have two right side forces now, W and F, and one left side force will be the resolved component of 980 Newton. So that is the equation here, plus W and plus 0.3 N, that is F, minus resolved component of 980 cos 70 degrees. So solving this by substituting the value of N in this equation, we will get W to be equal to 58.88 Newton. So that is the minimum value of weight W. That is the minimum value of weight W, which might cause just for the block to impend or slide downward. If you reduce the value of W lesser than this value, then it will begin to slide. At this value of W, it will be in the verge of sliding down. That is the inference of these two values. That is, in the previous case, W you got a higher value, and in this case we have got W to be a lower value. So with this knowledge, let's move on to a much more complicated problem, wherein this is problem number 3. So one block over another block. This problem will have one block over another block. Let's see this problem. Block A weighing 2001 Newton is placed over block B weighing 2020 Newton. Block A is tied to wall with a horizontal string as shown in figure. If the coefficient of friction between A and B is 0.28 and between B and the ground is 0.32, what should be the value of P to move the block? So let's look into the sketch. There is a block B placed over the horizontal surface, and another block A is placed on this block B. So weight of A is 2001 Newton, weight of block B is 2020 Newton. So block A is tied to the wall. Okay, so like this, the block A is tied to the wall with the help of a horizontal string, and this coefficient of friction between A and B, the surface interface between A and B has a frictional coefficient equal to 0.28, and between B and the ground, that interface, the coefficient of friction is 0.32. So what should be the value of P when P is horizontal, first case, and when P acts 30 degree upwards to horizontal, that is the second case you need to solve. So let's consider this first case, free body diagram for first case when P is horizontal. So that is given in sketch itself, when P is horizontal. So what is the free body diagram? So I'll choose the x-axis along true horizontal and y-axis along true vertical. So I'll first draw the free body diagram of A, and then I'll move on to draw the free body diagram for B. So block A is placed at the center. So weight of the block, that is the first force I always consider, 2001 Newton. So to this we will have a normal reaction N. Okay, I am writing here N1 because I will get another normal reaction for B. So two different blocks we have for that reason. So N1 acting in the upward direction. Next, this block is tied with a string to the wall. So a left side force, that is, there is a tension in the string, and so we represent it by the letter T, and that is a left side applied force, we can say. Next, just because this block is tied with a string in the left side direction, we can consider the friction to be in the right side direction. That means if this force has tension in it and tries to pull this block towards the left, so my friction force will have a direction in the opposite direction of the motion of the block, that is towards the right. So F1 I will consider in the right side direction. Why F1? Again I'll get F2 for block B in the in between the surface and block B. Well, this completes free body diagram for block A. Now let's look in to draw the free body diagram for block B. So I'll choose the x-axis at a lower level. The free body diagram of B will have, let's consider the block in the center. So the first force I'll consider on this will be the weight of block B, that is 20 Newton, and to this we have a upward force, that is the normal reaction force, that I will represent by N2, and we have a right side force P here to the block B, so that I'll draw here. Okay, so I have highlighted this P, so because that is the required force to be found. Okay, so this is the thing. Next, just because we have this force P to be acting in the right side, that is this force P tries to pull this block, so this block will be capable of moving towards in the right direction due to force P, and so the friction between the block and the surface I will mark in the left direction. Okay, hope you understood this. So just because P is pulling this block onto the right side direction, I will have friction to be acting in the left side direction. So after these four forces, that is the exclusive forces for block B, weight, normal reaction to the force to the block B, and the applied force P, and the frictional force F2. So along with these four forces, I should consider two more forces. Which are they? At the interface of A and B. Please students, don't forget this. At the interface of A and B, you need to consider two more forces. They are the normal reaction N1 acting in the opposite direction, that will impart a force in the downward direction. This N1 acting towards A will also impart a downward direction towards B. So this is the one force, and the next force is the friction between A and B. So that will be in the left side direction. You can either you can justify the direction of F1 in two ways. That is, just because F1 is on the right side, F1 for A is in the right side, F1 for B will be in the left side. Or just because this block is pulled towards the right, that is the motion will be in the right side, F1, the friction in between A and B for block B, it will be in the left side direction. So please note, we have 6 forces for block B and 4 forces for block A. So this is for case 1, that is when P is horizontal. Let's look for case 2, that is when P acts at 30 degree upwards to horizontal. What we have to do? See, they are asking only P should be inclined, only one force. Rest of the forces can remain the same. So what I'll do is, I'll not choose the x-axis along the 30 degree plane or something like that. as we did for the inclined plane before. But here my convenience would be to assume the true horizontal x-axis and true vertical y-axis, and only force P will be inclined at 30 degrees. So that is the free body diagram. So along with the same as FBD of B when P is horizontal, but the only change is this P is inclined at 30 degree. So you can ask me, what about free body diagram for block A for second case? So the answer is it is same, no change. Okay, only P is inclined at 30 degree here, no change with respect to block A. So let's solve case A here. So block A, for case 1 when P is horizontal, considering the free body diagram of block A. So this is the diagram we had considered. So applying conditions of equilibrium, that is sigma V equal to 0 and sigma H equal to 0. For sigma V equal to 0, upside forces positive and downward forces negative. So let's write the equation for the first condition of equilibrium, that is N1 upward direction and 2001 downward force. So plus N1 minus 2001 equal to 0. So this gives you the value of N1 to be equal to 2001 Newton. Next, since this entire case is for impending motion, so we consider F1 is limiting friction. F1, so you can use this formula, F1 equal to mu times N1. So that value of F1 works out to be 560.28 Newton. So with these values of N1 and F1, let's apply the second condition of equilibrium, that is sigma H equal to 0. So the sign conventions would be left side negative and right side positive. So which are all the forces? Right side F1 plus and left side T minus T equal to 0, or T is equal to F1. So F1 is nothing but we have found already. So the value of T is equal to 560.28 Newton. Please note these are the values we have found in this N1, F1 and T. Let me mark N1 and F1 in the free body diagram because these values are the same again to be used when we analyze free body diagram of B. So F1 and N1, they remain same, the extra two forces I had told you. So moving on to analysis of free body diagram B. So F1 we have considered same and N1 we have considered same, already found forces. Okay, so continuing this, considering the free body diagram of block B, so applying conditions of equilibrium, so sigma V equal to 0 and sigma H equal to 0. Sigma V equal to 0, so what are all the vertical forces? N1, N2 and weight of block B 2020. So they are the forces. Sign convention upward positive and downward negative. N2 upward, N1 downward and 2020 downward. So that's what we have here, minus N1 minus 2020, and N2 minus N1 is already we have the value. So please see here, N1 is equal to 2001 Newton. So that we substitute here and get the value of N2. So 4021 Newton. So F2 is also limiting friction. So you can use this relation, F2 is equal to mu2 N2. Mu2 value is given to be, what is mu2? Coefficient of friction between the block B and the surface. So that is 0.32 given in the problem itself, multiplied by N2. N2 value is 4021. Therefore F2 is equal to 1286.72. So considering these values, let's apply the second condition of equilibrium, sigma H equal to 0. Left side forces negative, right side forces positive. So we write the equation which are all the forces? P is the right side force positive, and minus F1 minus F2 are the left side forces. Substitute the value of F1 and F2 in this equation to get the value of P, which works out to be 1847 Newton. So for P in horizontal, acting horizontally, this is the answer we have found. So in the next case, we'll see when P is inclined at 30 degrees to horizontal, what is the value of P. So second case, when P is inclined at 30 degrees to horizontal, so only change is the inclination of P, rest all is the same. So again, N1 we have already carried forward from the previous that is analysis of free body diagram of A, and F1 also we have carried over from the previous. So considering the FBD of B for case 2, that is P is inclined at 30 degrees. So applying conditions of equilibrium, sigma V equal to 0 and sigma H equal to 0. Sign conventions for sigma V equal to 0, upside positive, downward negative, and this is the equation. N2 upward force minus N1 downward force minus 2020 is the weight of the block acting downward, weight of block B acting downwards, plus P sin 30 degree is the resolved component of the inclined force with the vertical plane, that is P sin theta. We are resolving this along the vertical plane. Resolved component of P with vertical is P sin 30 degrees. So with this, what are the substitutions that we can make is N1 only. So N1 value we have, so 2001 we write, and we get an equation. Let us call this as equation number 1, that is N2 equal to 4021 minus 0.5 P. Let's call this as equation number 1. So sigma H equal to 0, left side forces negative, right side forces positive. So let's write the equation. Right side force, that is resolved component of F along horizontal, is P cos 30 degree, and left side purely horizontal F1 and F2 minus F1 and minus F2 equal to 0. So F1 we know, F2 also we can find by using this relation, that is F2 is equal to mu 2 N2. So that is F2 is equal to mu 2 0.32 multiplied by N2. Take from this equation, N2 is equal to 4021 minus 0.5 P. So this is N2. From equation number 1 we are substituting the value of N2. So let's further reduce this equation and let's substitute the values of F1 and F2 in equation number 2. We get this P cos 30 degree minus F1 560.28 minus 1286.72 minus 0.16 P. So this is from this equation F2. So solving this, we have only P remaining. Solving this, we get the value of P to be equal to 1800 Newton. So this is the value of P required to cause impending motion of B, block B, when it acts at an inclination of 30 degrees with horizontal. So this completes the solution for problem number 3. So now I wish to give you an assignment problem. So problem number 4, what should be the minimum weight of W so that the block of 1000 Newton will not slide down the plane? Okay, so this block should not slide down the plane. For that, what should be the value of W? So this is block over another block problem, but in inclination, placed on an inclined surface. So students, please try solving this problem with the concepts what we have learned till now. And in the next videos we will take up problems on rope friction, ladder friction, and wedge frictions. And also I'll be giving you assignment problems at the end of those lectures, and in further videos I'll also solve all the assignment problems. So for this you have to subscribe to our channel Civil Ed, and please share with your friends and click the like option. So with this I complete this video lecture on problems on uh, blocks. Okay, that is the first set of problems for the under friction problems. Please, once again reminding you, subscribe to our channel and share it with your friends so that it reaches maximum engineering students. Okay, this is the best help you can make. So just help your friends by sharing this so that everyone can take up this learning. Thank you.